In this lesson, we're going to be able to write and evaluate logarithmic expressions and graph logarithmic functions. First of all is our warm-up. So this is a review of what you've already learned. Pause the video and solve each equation, then come back and check your answer. So what to the third power is equal to 8? Why 2, of course. What to the 1/4 power equals 2? Or we could look at 2 to the 4th power is equal to 16. 3 to what power is 27? That was pretty easy. And 4 to the power of 6 is equal to 4 to the power of 3 times 2. Very good. Our key concepts. Logarithm has base b of a positive number y and is defined as follows. If y is equal to b to the power of x, then we can rewrite that as a logarithm of base b of y is equal to x. Notice we set it equal to the exponent. Our base becomes a subscript with our logarithm. A common logarithm that uses base 10. So if there is no base written down, the common log would say that it has a base of 10. Just like square root, the index is assumed as 2. If it's not written down, if there's no base, it's assumed as a common log with base 10. First of all, we're to write in logarithmic form. This is our base, so log base 4 of 1 over 64 is equal to -3. We just take our exponent and write it over here. Looking at this one, our base is 6, so log base 6 of 36 is equal to 2. On this one, our base is 17, so log base 17 of 1 equals 0. Now let's write logarithms into exponential form. So we're going to go back the other direction. So 2 to the third power is equal to 8. What is our base on this one? You remember? Good. 10 to the third power is equal to 1,000. And on this one, 8 to the power of -2/3 is equal to 1/4. Excellent. Now let's evaluate log base 3 of 81. First of all, we're going to write it in logarithmic form. So we're going to let log base 3 of 81 equals x. We're going to convert it to exponential form. So 3 to what power is equal to 81? Write them with the same base. Base of 3, that way we can set the exponents equal to each other. So log base 3 of 81 is equal to 4. Let's evaluate log base 8 of 2. First of all, we're going to write it in logarithmic form. Then convert it to exponential. 2 is equal to 8 to the what power? Rewrite both of them with the same basis. 8 can be written as 2 to the third power. And then set our exponents equal to each other. 1 is equal to 3x. So log base 8 of 2 is equal to 1/3 because we divide both sides by 3. Very good. For a logarithmic function, the n is the inverse of an exponential function. So our characteristics, this function log base b of x, and y is equal to log base b of the quantity x minus h plus k. So we're doing some transformations here. The asymptote is where is going to be the x-axis, and this one it's going to be where x minus h is equal to 0 or x is equal to h. The domain, x is greater than 0 or x is greater than h, and the range for both of them will be all real numbers. So let's look at graphing log base 4 of x. By definition, log base 4 of x is the inverse of the exponential function y is equal to 4x, 4 to the power of x. So step 1, we're going to graph y is equal to 4 to the power of x. So in your function editor, put that in as your first equation. So y sub 1 is going to be 4 to the power of x. And then graph it. You may have to make adjustments to your window to get what you need to, but notice their scale is 1. And you really don't need to go any higher than y max of 4, y min of -4, x max of I'm sorry, 5, x max of 5, x minimum negative 5. That'll give you a good view. Then draw y is equal to x, okay? So 0, 0, 1, 1, 2, 2. And then choose a few points on this first line and reverse the coordinates. Remember, we reversed the x and the y. So you could go to second, look at your table of values, and reverse some of those coordinates in order to graph y is equal to log base 4 of x. Here we're asked to graph y is equal to log base 5 of x minus 1 plus 2. So first of all, you need to graph y is equal to log base 5 of x. So you can use the steps that you did before, or I'll give you a little preview of next time's lesson. In your graphing calculator, we're going to use the change of base formula. Go ahead and enter in log base x divided by log base 5. You can enter that in your graphing calculator on your function editor, and it will give you the graph. Then simply by shifting the points from the graph 1 unit right and up 2 units, you can graph y is equal to log base 5 of x minus 1 plus 2. Okay, let's practice a little bit on our own.